I'm Anil Kumar. Before getting into inverse functions, we will explore one-to-one functions. The key is that only one-to-one functions can have inverse as a function, right? So that is why we are now exploring one-to-one function under inverse functions. So we'll cover up these topics. What are one-to-one functions? Quick test for one-to-one function. There are basically two tests. One is called horizontal line test. The other one is that the value of the function at A is not equal to value of function at B. It implies that A is not equal to B, which could also be said as value of function at A is equal to value of function at B. It implies that A equals to B. Right? So this is the other way of saying the same thing. We'll explore these properties shown above of one-to-one function with some examples. Specifically, we'll take up these 4 examples. Then after this, I'll have few review questions for you to do. I hope that will give you good insight to what one-to-one functions are, and then we'll explore inverse functions. So let's begin by understanding what is one-to-one function. Let me give you some examples first. Mapping diagram is a nice thing to begin with. It clearly indicates what we are trying to show here. So let's say these are the two groups, and that is how they are related. Okay. Now, in this case, you can see that each element in domain corresponds to one element in range. Correct? So each element here corresponds to only one element. You also see that each element in range is linked with only one element in domain. Clear? So that becomes one-to-one function. So that is how we actually see what one-to-one function is, right? Let's take few more examples to illustrate. We could have, if I write in the form of coordinate points, then the set like this, -1, 2, 3, 4, let's say 5, 6. Now you see all elements in domain are unique and all elements in range are unique. So these are one-to-one functions, correct? If I have to draw a graph, then we can draw a graph of few functions which are one-to-one functions. For example, a straight line is a one-to-one function. I could sketch a function which is kind of like this. It is one-to-one function, correct? So all these functions which I've kind of shown you here are one-to-one functions. We could have a function kind of like this also, all right? So these are all one-to-one functions. So what you notice here is that the one-to-one functions are, you will say, always increasing, or they're always decreasing. Correct? So that is also kind of very important characteristics which one-to-one function will have. So all these are good examples of one-to-one function. Now, let me give you a few examples of functions which are not one-to-one. So we'll sketch few. For example, if I draw a parabola, is it a one-to-one function? Think about it. How about this? Is it a one-to-one function? Or a semicircle, for example. Now, in these examples, what you notice is that for a particular y value, let us say this, which is same, we have two x values. Do you see that? Here also, we see that if I draw a horizontal line, it cuts at different points on the graph, more than one. All these points have fixed y value but different x values. You see that? In this case also, if I draw a horizontal line, then it corresponds to two different x values. So what we have shown here is that the value, let's say value b for y corresponds to, in this case, minus a and a, two different values. Correct? So this is not one-to-one. To give you an example, if I have y equals to x squared as our function, then the point which is, let's say, if the x value is 2, in that case the y value is 4. And we also have a point where x value is minus 2, y value is 4. So this is not one-to-one function, since what you notice here is that if you're trying to map the points, the point in the domain which is 2 maps to 4, and which is minus 2 also maps to 4. Right? So it could be shown as 2 and minus 2 are mapping to 4. So therefore, it is not one-to-one function. One value in y has been mapped to two values in x. It is still a function, but not one-to-one. You get an idea, right? So I could actually write functions of the form, let's say, let me give you a few examples here. Y equals 2, let's say 2, 3, 3, 4, and 5, 3. Now in this particular case, the y value of 3 has been repeated. So that is why it is not one-to-one. You will also notice that these functions are combination of increasing and not increasing. You get an idea. Or you can say decreasing, increasing. Now, why am I saying combination? As I could give you one more example in this list, which is kind of like this. We could have a function which may look like this. Now, in this particular case, you will notice that for all these values, y value is constant, right? Let's say y value is 10. Then what we notice here is that for different x values, we have same y value. So it is not one-to-one function. You get an idea, right? This type of a function is kind of many-to-one. Many values are linked to one value in y. So now you have a clear idea of what are one-to-one functions and what are not one-to-one functions. Now, to summarize this, we have some tests which could be performed to figure out whether a function is one-to-one or not. Now, let me tell you two tests which could be performed to find whether a function is one-to-one or not. So these are horizontal line test, and algebraically we could prove one of these two conditions. So let us see what is horizontal line test first. Horizontal line test is done on a graph. So we'll actually sketch few graphs, then you will understand what we're trying to say. So if I draw a graph of a cubic function, let's say like this, coming downwards, you see it is always decreasing. And if I draw a horizontal line anywhere, it only intersects at one point. Perfect. On the other hand, if I sketch a function which is kind of like this, now here, drawing a horizontal line, we will see that it intersects the graph at more than one point. So this is not, but this is one-to-one function. Is it okay? So that is the kind of test which we could do. A semicircle, for example, if I draw a horizontal line, it will intersect at 2 points, and therefore it is again not a one-to-one function. If I have a function which is, let's say 1 over x, in that case, any horizontal line which only intersect at one point. So basically, horizontal line test is that for one-to-one function, horizontal line intersects the graph at only one point. But if it intersects at more than one point, it is not a one-to-one function. You get an idea, correct? So that is what it means. Now here is the second method. So this is method number 1. Now we'll talk about the second method, which is more algebraic in nature. So we try to say that a function is one-to-one if for each element in the domain, let's say for each element A and B, let's say 2 elements. For each element A and B in the domain of the function, if A is not equal to B, that implies that f of A is also not equal to f of B. You get an idea. So for each element A and B in the domain of the function, if A is not equal to B, implies that f of A is not equal to f of B. Right? We could also say this as if A equals to B, f of A equals to B, that means A equals to B, right? So that is what is another way of putting the same thing, right? So what we are trying to say here is that, let's take an equation, for example, y equals to 2x plus 3. Now what is f of A equals to? F of A is 2a plus 3, and f of B is 2b plus 3. Now if a equals to f of b, if they are equal, in that case 2a plus 3 should be equal to 2b plus 3. 2b plus 3. So when you can simplify this, 3 and 3 cancels, it implies 2a equals to 2b or a equals to b. Do you see that? Since a equals to b, for f of a equals to f of b, we can say since a equals to b, for any f of a equals to f of b in the domain of f, the function y equals to 2x plus 3 is 1-to-1 function. Is that clear? So algebraically, we could prove like this, that a function is 1-to-1 if for every element a and b in the domain of the function, if their values are same, then a and b are same. Correct? So that is what it is. So here are now a few questions which you could explore. So this is kind of a test exercise for you. So let me see how you can prove it. So what we will do is, we'll give you a few questions to work. You can pause the video, copy these questions, answer and write which of the following are 1-to-1 functions, right? So explore and test properties of 1-to-1 function. So let me show you a few graphs here. One of the graph will be kind of like this. Let's say absolute function. We've done this. Let's say a parabola. And let me take a function which is correct. So these are the functions. You need to tell which of the above these are or is 1-to-1 function. Let's name them A, B, C, and D. Now let me give you a few equations also. You can do algebraic solutions for those equations. So let me call them E. F of x equals to 1 plus x over 1 minus x. F. Y equals to square root of 25 minus x square, right? So I like you to show if these are 1-to-1 functions or not, right? So use the property which we talked about, that f of a equals to f of b implies that a equals to b. Now in this case, you can find points, find x equals to something which is, let's say, a and b, so that f of a equals to f of b, right? In that case, you will note that this is not a function, not a 1-to-1 function. Is it okay? Now we are going to take these 4 examples and check which one of these is 1-to-1 function. So we'll apply the algebraic method learned to prove whether it is a 1-to-1 function or not, right? So let's take these two. We have a linear function, f of x equals to 2x minus 1. So let's say that there are, let's say f of a is an element in the domain of 2x minus 1, then f of a will be equals to 2a minus 1, and f of b will be 2b minus 1. Now we need to show that if f of a equals to f of b, then for one-to-one function, the condition is that if f of a equals to f of b, then it implies that a equals to b, correct? So that is what we are going to show. So if f of a equals to f of b, in that case, we'll have that 2a minus 1 equals to 2b minus 1. That means 2a equals to 2b or a equals to b. Do you see that? Since we get that a equals to b, for f of a equals to b, we know this is a one-to-one function. Correct? Now let's do with the second question. Now let's take a point which is, let's say, f of a equals to a square minus 1. F of b will be b square minus 1. And if f of a equals to f of b, in that case, a square minus 1 equals to b square minus 1. So we have a square equals to b square, or we have a equals to, so a could be equals to plus minus b, right? So a could be equals to plus minus b. So a corresponds to two values, not just one value, correct? So for two different values of b, we have a value of a, correct? If you want to do it with a graph, it is kind of simpler and faster. If you sketch this graph, you know this is x square minus 1. Graph will be kind of like this, where this point will be minus 1, and any horizontal line will cut at 2 points. So you could say that it fails horizontal line test. So it is not one-to-one. Right? So that is also possible, but algebraic solution you could do as shown here. Right? Now let's take another example, which is kind of complicated. Now in this case, let's choose points a and b. In that case, f of a is equals to 2a plus 1 over a minus 1, and f of b equals to 2b plus 1 over b minus 1. Now if f of a equals to f of b, in that case we have 2a plus 1 over a minus 1 should be equal to 2b plus 1 over b minus 1, correct? So let's cross multiply. So we get 2a plus 1 times b minus 1 equals to 2b plus 1 times a minus 1. Expand, so we get 2ab minus 2a plus b minus 1 equals to 2ab minus 2b plus a minus 1. Now common terms get cancelled. So we are left with, so bringing a's and b's together, what we get here is bringing b's to one side and a's to the other side. We get b plus 2b equals to a plus 2a, and that implies that 3b equals to 3a, and that means a equals to b. Do you see that? So if f of a equals to f of b, then for all a's and b's, a equals to b. That means this is a one-to-one function. Is that clear? Right. So this is one of the very important examples to prove that the given function is one-to-one, correct? You will also graph and see whether it is always increasing or decreasing. Now let's take another example, and here we'll have an alternate approach. to show that it is not a one-to-one function. Right, so we'll have kind of alternate approach to show that it is not a one-to-one function. So let's take points as x equals to, let us say, plus 2, and let's take x equals to minus 2. So these are two different values. So we know plus 2 is not equal to minus 2, correct? But what is f of 2? F of 2 is equals to 4 minus 2 square, which is square root of 4 minus 4, which is 0. And what is f of minus 2 equals to? That is also 4 minus minus 2 square, which is 4 minus 4, which is again 0. So what we notice here is that 2 is not equal to 2. However, f of 2 is equal to f of minus 2, and therefore it is not one-to-one function. Is that clear? Right? So that is how you could show very easily that this is not a one-to-one function, correct? So if you sketch, you're going to get a semicircle with like this, correct? So which fails a horizontal line test, and these are the two values which we are talking about. Both give you 0, right? Now for you, these are 6 questions to practice. I'd like you to pause the video, copy these 6 questions, and prove whether they are functions or not. They are all functions, whether they are one-to-one functions or not, correct? So that is what you have to do. Write your comments, and then we can discuss if there is any difficulty. Feel free to share my videos, and if you like and subscribe to them, that'd be great. Thanks for watching, and all the best.